Hello, Pinky. Is my screen visible?
Yes, ma'am.
Okay. So, good afternoon, everyone. I'm Rakhi Yadav, your PMRF teaching assistant, doing PhD chemistry at IIT Bombay for pericyclic reactions and organic photochemistry course, which is conducted by NPTEL, and whose course instructor is Professor Sankara Raman from IIT Madras. So, students, till this point, we have reached to week 7, which is about organic photochemistry. In last video or session, I have discussed in brief the theory part of organic photochemistry, that Jablonski diagram, and we have discussed two laws of photochemistry also there. So, for competitive exam point of view, you can refer to that slides. Today, we are going to cover photochemical reactions. So first basic reaction of photochemistry that come is your Norrish type 1 and Norrish type 2. Both reaction differs in a way that your Norrish 1 is your alpha cleavage reaction. See, let's say this ketone is there, right? So you have to cleave from this alpha position. If you cleave from here, two radicals will form. One is this acyl radical and one is this R dash radical. They can combine. How they can combine? In a two ways. First, CO will leave from here, okay, and then this radical will combine with this R dash, right? It will cleave from here. Another type of reaction is Norrish type 2. First, we will have brief recap of all these reactions, then we will solve problems. Students, Norrish type 2 reaction is a alpha cleavage reaction. So start numbering. Your alpha carbon is which? This or this? Alpha carbon means carbon next to carbonyl. Okay. So alpha, beta, gamma. Understood? Here also, let's say this R dash is CH3. So this is your alpha carbon. So keep this thing in mind that alpha carbon, alpha carbon is carbon next to carbonyl. Okay, good. So here students, alpha, beta, gamma. On gamma carbon one hydrogen is there. Okay, so this will cleave. And here you can write this C double bond O as a C dot O dot. That O dot will take this gamma hydrogen and will form OH, leaving behind radical. Now there are two possibilities, students. One is this fragmentation which they have mentioned. Okay, if this bond breaks, radical will come here and you will get this acetone and this olefin. Till this part clear? But one another possibility is also there, students. This four member ring can form. One, two, three, four. Actually, pen tab is not working properly. So on carbon number one methyl is there, one OH is there. Then two, three, okay, two, three. And on fourth carbon, one methyl is there. This is also a possible product in your nourish type 2 reaction. Clear?
Yes, ma'am.
Okay, good. If clear, so this is the problem number one for today's session. Tell order of alpha cleavage rate of the following carbonyl compounds. Take 30-second time and think.
Ma'am, A is the fastest one. A, B, C,
Okay,
D.
you are saying, so according to you, answer is A, B, C, D, right?
Yes, ma'am.
Can you tell me the reason?
Ma'am, ring size, the ring constraint.
Exactly. Very good. So you have identified the correct explanation of this. More is the ring strain. More is the ring strain. Faster will be the faster will be the rate of alpha cleavage. Very good. Okay. Let's move to next problem. So this is the major product formed in the following reaction is. Take again 30-second time and start solving. Or guide me how to start. In today's session, what will be the sequence? First, we will have brief recap of that particular reaction. What is it? And then we will solve questions based on that reaction. Yes, tell me. Okay, till now I
Ma'am,
have just taught you two
last,
reactions. Nourish type 1 and 2. You are saying last.
last one.
Okay, so your answer, you are going with, where is my pointer? Huh? Fourth one. Okay, let's see. See, students, there are two possibilities. One, we have read that nourish type 1, alpha cleavage. Okay, but alpha cleavage product is nowhere. One, that this CO should leave. Another possibility is that this ring has not broken. In every case, six membered ring is there. Yes or no?
Yes, ma'am.
So it means that alpha cleavage will not happen. Then what will happen? Let's draw that. See how to do nomenclature. Alpha, beta, gamma. Now see, students, if this hydrogen got cleave here, what you will get? This is your gamma hydrogen abstraction. Yes or no?
Yes,
Am
ma'am.
I correct this point? Now just you have to combine these radicals and you will get option number 4. So again your answer was perfectly correct. So correct answer for this is option number 4. Now you may think for other options also, but they are not possible, right?
Yes, ma'am.
Yes. So your next reaction is dipymethane rearrangement. This was first given by Zimmerman in 1967. So here student you will see skipped dienes. Skipped dienes. What do you mean from that? See, if I draw a double bond here, then these two double bond will be in conjugation. But dipymethane rearrangement problems have these two dienes not in conjugation. So they are not in conjugation by one carbon. So that's why they are known as skipped dienes. Because their conjugation is skipped by one carbon. Understood? So
Yes,
from here you can identify that this may be the starting material required for your dipymethane rearrangement. Now let's have a quick look at its mechanism. So, okay, let me use laser. Huh. So this is your starting material. Okay, skip dye. You are irradiating this type of compound with H mu light. Since double bonds are there, transition involved will be pi to pi star. No doubt in that,
yes,
right?
ma'am. Yes,
Someone may ask, what type of transition will this type of compound may undergo? And they will give you three options: pi to pi star, n to pi star, sigma to sigma star, or first and third. What you will say?
Fight first.
N to pi star, because there is nothing having there is no atom having lone pair in it, right?
Mm,
So okay, so first on H mu, this is your reactant, this is your excited state reactant, that's why they have written as R star. Now your first task is to make a radical, diradical. Okay, once you made diradical on one side, another side will also open. Then this radical and this radical will combine and will form cyclopropane. Correct?
yes, ma'am.
Now let's say you have first make diradical here. So in another, if you are making diradical from left side, you have to break right side cyclopropane bond, not this one. If you will break this bond, this radical will combine with this and here you will get olefin. Why? If this bond will break, here radical will come, radical will combine and will form alkene. And you will get this vinyl cyclopropane. Is this mechanism clear to you?
Ma'am, can you repeat the one that which one to be
Okay.
cleaved?
Let me give you a simple example, then you will understand. We will go step by step. Okay. See, here it is a symmetrical system. Let me give you some Me, Me, and here let's say I am giving you hydrogen, hydrogen. Okay. Now your step one is student. Okay, if I say you make radical, you will make radical on which side, left or right?
Left side, ma'am.
Because radical will be more stable on two Mes rather than two hydrogens, right? So your
Mm,
step one is make diradical on more stable olefin side. Okay. So till this step you are very clear that you have made radical, radical, radical. Now your next step is you have to make again diradical, but four radicals can't be there in one structure. So as soon as that radical will form, it will form cyclopropane. Understood? Like
mm.
this. Clear?
Yes,
this
ma'am.
this will cleave radical, and then this radical will combine with this, will form cyclopropane, and you will get this intermediate. Clear?
Yes, ma'am.
Then I said you one line that you have started from this side, yes or no? So you have to
Hmm.
break this bond. You can break three bond. This. Let me number one, two, three. But if you break bond number two, then there is no use. You will get to your starting material. Now you are
Hmm.
left with two bonds, either one or two. So I said, keep break the bond which is opposite to the side at which you have started to make biradical. Why? See, if you make if you break this bond, radical will come onto this carbon, and you
Hmm.
know that among this radical, left side radical and right side radical, which is more stable? Left side.
Left side.
So
Hmm.
since this is not stable, it will react faster, and it will combine with this radical and will form what? Olefin here. Sorry for this. It will form olefin here, radical. Since this bond has cleaved,
Hmm.
can I write it like this?
Yes,
Now
ma'am.
these two radical will combine and will forms your cyclopropane. Now tell me, is this clear or I should explain again?
No, it's clear, ma'am. Now it's clear.
You will get this product.
Hmm.
Yes or no?
Yes,
So,
ma'am.
one conclusion which you can make from this slide is on which on which side of olefin your cyclopropane will form, which is more stable.
Hmm.
Let's say here Me and pH are there. So that
Hmm.
cyclopropane will form here because pH will stabilize that radical more in comparison to your Me.
Hmm. Hmm. Okay.
Understood na?
Yes, ma'am.
Okay. You go through this example also, try by yourself and then we will discuss this. Okay. This is also a good example of your Zimmermann reaction. You first solve by yourself, then we
Ma'am.
will discuss. It is very interesting. Okay. So, if the reaction is very clear to you, take 1 minute time and help me in solving this problem. Are you solving? Right?
Yes, ma'am.
Okay, okay.
Sorry.
Take your time.
Ma'am, five-member ring will form now.
In
Oh,
first, right? Okay, let
uh,
me solve also. I don't have answers. So, as I know you have understood this, so you have made first radical at this side, right? You can
yes.
identify na this is skipped diene. So
Yes, ma'am.
the this is starting material for dipyrmethane. In this way, you have to identify. Clear till this point? Now,
Yes.
first you have made radical, so you have to break this bond. So it is very clear from here. pH and this. Clear? I hope
Yes, ma'am.
this is your answer.
Yes, ma'am.
Very good. Okay. In this question, what is your answer?
This is, ma'am, like previous one only, and three-member ring will form to avoid
Exactly.
the
Exactly. Right? Am I
Yes,
correct?
yes, ma'am.
Okay. Very good. It means you have understood now. Okay. Next photochemical reaction is student Barton reaction. How you will identify that Barton reaction is there? You will have okay, starting material is not there. Okay, no issue. If you are given ROH student and on arrow it is written NaNO2 in presence of HCl. What you will get? RONO. How you will get this? You figure out by yourself and then we will discuss at the end of the class. Okay. Once ONO bond will form and you are irradiating this compound with H mu light. So one thing is clear, which bond is weakest in this system? Obviously the bond which is between two heteroatoms, right? Due to lone pair repulsion, they are most reactive for cleavage. Once this bond has been cleaved, this will become O dot and now see alpha, beta, gamma, delta. So Barton reaction is the story of student delta hydrogen cleavage. Norwich type 2 was gamma hydrogen. Norwich type 1 alpha cleavage. And here you are uh, observing delta hydrogen cleavage.
Mm.
Okay, this hydrogen will cleave, OH will form here. Now, since this
Mm.
NO radical has eliminated in first step, this will again combine with this, will form this type of intermediate. Now, this NO can undergo tautomerism, will form this oxime, and now it is very clear that this oxime under hydrolysis will form aldehyde. Yes or no?
Yes, ma'am.
C double bond O H. So
Mm.
in total, if we see what has been there, that any delta hydrogen which is present to OH alcohol will convert into aldehyde. Okay, that is your Barton reaction. Clear? If not clear, it will be clear from problems. So solve this problem. The major product formed in the following reaction is: first you have given NOCl, it will what it will form? ONO, right? Then you are irradiating this compound with H mu, and last step is your HCl. HCl will basically hydrolyze your that oxime to aldehyde. Quickly solve this.
Mm. Ma'am, option A.
Sure.
Yes.
Yes, you are correct. If we see how many possible positions are there: alpha, beta, gamma, delta. Alpha, beta, gamma, delta. Okay. So one thing is very clear, that these two positions are most sterically less hindered, to which can your abstract this anodode. Okay. But now my doubt is, among this axial and equatorial one, why have you chosen axial one?
Ma'am, the axial position was there in the same side, and there means uh, same side, and that is closer compared to the equatorial
Very
one.
true. Very true. So that's why, since you have identified the correct delta carbon connected to hydrogen, you just have to convert that carbon to aldehyde, CHO. Understood?
Yes, ma'am.
Okay. So next reaction is D-Meio's reaction. How you will identify it? You will be given 1,3-diketone as a starting material. Your first step should be write one of the ketone in its enol form. Okay. Then then do 2 plus 2 cycloaddition between your given olefin and formed enol, right? So what you have done is you are given this diketone, you have written one of the ketone into alcohol form, sorry, enol form. Now you have to do 2 plus 2 cycloaddition between these two olefins. Okay, you have made this compound. Now if you look at this, you are see alpha beta. This is your beta hydroxy ketone, and you very well know that if there is anywhere beta hydroxy ketone, it can undergo your retroaldol reaction, right? Retroaldol means your oxygen lone pair will go there. Now, which bond will cleave? This bond. Okay, this bond will cleave, and you will get 1,5 diketone. So anywhere, if you are observing that 1,3 diketone is converted into your 1,5 diketone, right? Then it is your D-Meiosis reaction. And if you look at overall change, what has been done? COR3, COR1. Okay, COR3, COR1. Just they have written by flipping. In between those carbons, your one olefin has inserted. Yes or no?
Yes,
This is
ma'am.
oh sorry. This is carbon carbon of your olefin. This
Mm,
R5 R4 R5 R6 R7. Clear?
mm.
Just you have to break one of the alpha bond, not break, actually just cut from here, paste this olefin there, and you are done. If in
Mm.
exam you have to directly write product, you will write in this way. Clear?
Yes, ma'am.
Very good. If clear, do this question, take 1 minute time.
One, two.
What is your first step?
First step will be that OCOPH that will cleave, ma'am, because
Oh, you will cleave OCOPH.
where is that 1,3 diketone here?
See, this is also your 1,3 diketone. Yes or no? Because here, if you replace OH with OCOPH, this is your 1,3
Mm-hmm.
diketone. Okay.
Mm-hmm.
So this is one of the variant which you may come across in your exams. Understood?
Acha, acha.
Your 1,3 diketone looks like this. Double bond
Mm.
OH. This is your 1,3 diketone.
Yes,
Okay.
ma'am. Mm-hmm.
Just they have replaced that OH with OCOPH. Now do the problem. Do step by step, you will reach to answer. Till that, I let me also solve this.
Mm. Writing this is very difficult, ma'am.
Yes, but do step by step, you will get to this.
I have done the same.
See, this is your four-membered ring, this is your five-membered ring, this is five, and newly formed will be of
Four,
one, two,
two,
three, and
four.
four-membered ring. So we have
Mm,
made it correctly. Just we now we have to make that five-membered ring, right? So
mm,
best way to do this is do numbering. You can do numbering in your way. Just I have done random numbering so that I can connect. So let's see. This one carbon is two connected to two, then three, right? One, two, and three. Till this point, everything is correct. Then this two is connected to A, E.
mm.
Okay, A and E is connected to three. So till this point, everything is correct. Now
Yes.
3 is connected to 4. This. Okay. And this
Mm,
1 is also connected to here.
mm.
So this is your. Okay. Are you clear with numberings? Because I
Yes.
have just done some confusion here. Wait. Now you will be clear with numbering. Okay. Okay. Now tell me which carbon should I connect? E to F,
E to
F to
F, F
G.
to G, G
Okay.
to H. Five member ring.
This is your G, this is your F, which is connected to this. Now everything is clear. This is perfect. This is the correct intermediate till this point.
Yes, ma'am.
No doubt till this point. Now tell
No.
me what will be your next step.
Next step, ma'am, on the breaking of the first OPH, I think it will go up.
That
OC,
OCOPH will convert into
OH.
OH. Very good. And
Then that alpha bond,
then your retroaldol reaction.
electron.
Then your retroaldol reaction. But now the thing is, this oxygen lone pair will come down. Which bond will create this 1 2 or two, or 1 2 or this one? Obviously, this 1 2 bond will break, right?
Um,
So how many membered ring will form? One, two, three, four, five, six, seven. Seven membered ring, right?
mm,
Yes or no?
mm,
Or is there any confusion? So let me show you. This is your five membered ring, this side one.
mm,
This is your four membered ring, one, two, three, four.
mm,
Okay, that bridging carbon is that is connected to your five and four membered ring. Obviously, this 3E. Okay,
mm.
this 3E are the two bridging carbons, these bridging carbons.
Mm.
Is there any confusion? Okay,
Ma'am, only
okay, let me
one
write that
bond is.
final product, then I will tell you.
Mm.
Okay, wait. Clear till this point? Now you have to imagine how you will write from this structure to this. Okay, so
Mm.
see, Now you have to identify, this is your 5 membered ring. Okay.
mm,
And this is your 4 membered ring. One, two, three, four.
mm,
And the carbonyl, alpha carbon to this carbonyl. Now this connected to 7 membered ring. Clear?
mm,
And this 7 membered ring is connected to this 5 membered ring from here. And you can see that connectivity here. So what is
mm,
your take home homework from this is, you just do numbering and then convert into this. Okay, have you understood? Do
mm,
numbering like this: 1, 2, 3, 4, 5, 6, 7. Done. Then A, B, C, or then D. Done.
mm, mm,
Now if you see, this is your carbon number 2, 3, 4, 5, 6.
mm,
Correct? This is your carbon number 1.
mm.
Till this point, everything is clear, right?
Yes, ma'am.
Okay. Now this carbonyl is carbon number D. This is your A. Now your 5 membered ring will start. A, B, C. Okay. Your C
Mm,
carbon is connected to your carbon number 1. So here we are somewhere wrong.
mm, mm.
Can you identify? One, 2, 3, 4, 5. Can you identify where we have made mistake here? Your 6 carbon is connected to carbon number D. Okay.
Mm.
D is connected to A.
A
A is
is
connected to B. B is connected to C. And C is connected to 1. And this is your carbon number 7. But C is not connected to carbon number 7. So
mm,
somewhere we have done mistake here.
C is correct. Yes. Mm, one C B E
1, 2, 3, 4, 5, 6, and 7. Okay, we will come back to this problem at the end of the class. Okay. After solving all the problems, we will again come to this problem and see where we are doing mistake in converting this to this. Either this solution has problem or we have done mistake. Okay, we will check. If you find mistake, please tell me. Okay.
Mm.
Shall we move ahead?
Yes, ma'am.
Okay. So this is your second problem. Tell me how you will approach this. You solve this till then I let me solve this also. Okay. You solve this.
I'm done.
Okay, so tell me.
Ma'am, first is
First, 2 plus 2
olefin.
cycloaddition, simple, and then your retroaldol reaction. This OH will go there. Now you may think, ma'am, which bond to break? Obviously, if you will break the bond, here
Yes.
negative charge will come. So this is
Hmm.
the most suitable position for negative charge to come, as it is next to carbonyl. Yes or no?
Yes,
So
ma'am.
that's why you have to break this bond and you will directly get this product.
Hmm.
Let me write also. Example for D-Myos reaction. Now this oxygen lone pair will shift here, this bond will break and you will get this. Clear? Very
Yes.
good. So next reaction is your student Paterno-Bucchi reaction. So this is the reaction 2 plus 2 cycloaddition but between your olefin and your carbonyl compound. Okay, and you will get these regioisomeric oxytanes. Four-membered ring having oxygen in it is known as oxytane. Okay. I will solve first question for you, then you will solve next. Okay. Okay. You know that this is not carbonyl. Okay, let me give you simple example. Let's say you are having acetone and your olefin with 2 methyl. Okay. Just for sake of simplicity, draw radical here. O radical and here. I am explaining here how you should draw correct regioisomer. Okay. Wait. Now, student, tell one thing you should keep in mind in radical chemistry. Least the stable. Okay, let me write here. Less is the stable. Less is the radical stable. More it is reactive. Okay, more it is reactive. So, if I ask you among this radical and O radical, which radical is stable? This carbon radical. Okay, because this radical is on electronegative atom like oxygen. And among these two radical A and B, which is which is less stable? A, right or
Hmm.
no?
Yes, ma'am.
Okay. So what you have to do, whatever the least stable radicals are with you, you just combine them. Okay. And you are now left with B and this. And at last you just have to combine those. So in this way you have to write product for Paterno-Bucchi reaction. If everything is clear, please solve these two problems. Take 1 minute time, then we will solve. You understood na regioselectivity?
Yes, ma'am.
Okay. Okay, let me start solving for you. If you look at this,
Hmm.
don't think for 4 plus 2, right? Why?
Yes.
Why here
Hmm.
4 plus 2 is not possible? 4 plus 2 requires thermal condition.
Yes, ma'am.
Yeah,
It is total.
don't forget your basics. Okay, now tell me among these two radical which one is stable. Let me number A and B. And here C and D. My first question to you is in this first structure, uh, what is this moiety called? This five-membered ring with one oxygen.
It is pure no.
Furan.
Mm.
Okay. So among A and B radical, which is stable?
Radical A is stable, ma'am.
Why?
Ma'am, it will form bond with oxygen atom.
Exactly, and that is known as mesomeric effect. Okay,
Mm.
so this is most more stable. This is least less stable, or less stable, more reactive.
Mm.
Among these two possible, this is your least stable. This is your more stable.
Yeah.
Okay, so now nothing is left here. You just have to join the least stable one to each other and more stable to each other. Is this product clear to you?
Yes, ma'am.
Now it is correct. Clear na? It is clear.
Yes,
I hope now you can draw correct regioisomer of this Paterno-Bucchi reaction.
yes, ma'am.
You understood why we are combining two less stable radical to each other?
Yes,
Because they
because
are
they are
that
more
much
reactive.
unstable that they are
Mm.
reactive and they
Mm.
combine.
Yes,
Exactly. Okay, start solving second or tell me the answer. Can I erase this part, below part?
yes, ma'am.
Okay, okay. So, radical, which according to you is more stable. And one thing you should remember that in radical chemistry, electron withdrawing group also stabilizes free radicals. Okay,
Yes, ma'am.
captodative
Yeah,
effect.
this
Huh.
one reaction with keto with olefin, na?
Yeah, you are right. But here we can here they are basically simple 2 plus 2 cycloaddition. They also takes place in H mu na. Yeah, you are correct. Paterno, which is a reaction between your carbonyl and olefin.
Mhm.
But here in slide problem is for 2 plus 2. I will bring in summary session Paterno-Bucchi problems also. Okay.
Ma'am, how to then find out? This means when it will be Petranobuki, when it is 2 plus 2.
Very
When,
easy when there is simple cycloaddition between two olefins, means carbon carbon both side.
hmm,
That olefin are containing two carbons in it. So this is simple your 2 plus 2 cycloaddition. But when one of the olefin gets replaced by carbonyl, C double bond O, and you are getting oxytanes, right? This
hmm,
behaves
hmm,
as your olefin. Then it
hmm.
is known as Paterno-Bucchi reaction. But both of the reactions take place in photochemical condition. Okay.
But ma'am, here alpha beta unsaturated carbonyl also present, no?
Yeah.
Then why not in that position that reaction will happen? Means why
Okay.
oxygen won't
So
form?
in this case, tell me whether it will react with that carbonyl or olefin. Yeah. Good. Very good question.
Okay, here CN that radical. CN will be towards that keto group if that four-member ring will form.
Yeah. And could should will you tell me the reason or I should tell you the reason.
Because those two radical, the radical towards the CN that is more stable, and here the radical towards the carbonyl is more stable. So they will combine, and the
No,
answer.
my question to you is this olefin can undergo 2 plus 2 cycloaddition with this carbonyl also. Then why it
Hmm.
is undergoing 2 plus 2 reaction with this olefin? This is my question to you. Understood?
Yes, ma'am.
And my next question to you is, and if it is going 2 plus 2 with these two olefins among A and B, which is more stable? Or not stable, which is major?
That B is major, ma'am.
B is major. Okay, correct. B is major. Now tell me why it is not going undergoing Paterno-Bucchi. Because student, you
Ma'am,
very well know that your CO carbonyl is already electron deficient. Yes or
yes,
no?
yes, ma'am. Hmm.
So it requires olefin having some electron density in it. So if you this is your electron deficient olefin. In
Hmm.
chemistry, everything is the reaction between electron rich and electron deficient. Okay,
Yes, ma'am.
so
Hmm.
here these two will react. This is electron deficient. If we look at electron density of this CO and C double bond C, this has
Hmm.
more electron density, right? Why?
Hmm.
Because in C double bond O, almost all the electron density is taken by your oxygen atom.
Hmm.
Clear? So
Hmm.
this is more electron rich double bond rather than C double bond O. That's why it will undergo 2 plus 2 cycloaddition reaction.
Hmm. Hmm. Hmm.
I hope now it is clear.
Yes, ma'am.
Okay, very good. So I think this is your last name reaction in this photochemical. This is a Hofmann-Loeffler-Freytag reaction. What happens in this is, wait, you will be given amine and in presence of H plus, and that nitrogen will be connected to your heteroatom. Okay.
Hmm.
In presence of H plus, what will happen? Obviously, only nitrogen is having lone pair. Now you
Hmm.
will say, ma'am, halogen is also having lone pair. But which is more basic? Which?
Nitrogen.
Obviously nitrogen. So nitrogen will abstract this proton and will become NH positive. So in
Hmm.
presence of acidic condition, it will become this intermediate. Now H mu is given. So you see alpha, beta, gamma, delta. It is like your Barton reaction, yes or no?
Hmm.
So
Yes,
it
ma'am.
will, let me write here, alpha, beta, gamma, delta. So delta hydrogen abstraction. Why hydrogen abstraction? It will become H plus X negative. Actually, it is not ionic mechanism. It will go radically. H dot and X dot will meet, will become HX. So minus HX. Okay. And now these two will meet. One, two, three, four, five membered cyclic amine will form. Understood?
Yes, ma'am.
So this is the mechanism for this. I hope it is clear to you.
Yes, ma'am.
Okay. Last but not the least, wolf rearrangement is also there. So let me explain from here as it is in blur. Let me write for you. Can I write this N2 like this? Oh, wait, I have done mistake here. Let me rewrite it. Here nitrogen is having, yeah, ask. Here nitrogen is having four bonds, so that's why it will be having positive, formal positive charge. And here two bonds, so negative charge. If you write its resonating form, for resonating form, this arrow is used, okay? This is negative, N triple bond N positive or negative. Clear? Now you very well know that this N2 will leave and will form here carbene. If you have attended my previous lecture, I have seen carbene is nothing but is carbon having both positive and negative charge onto it. Okay. So this N2 will leave here as a neutral molecule, leaving behind here positive charge. And that
Mm.
positive negative will be neutralized, right? I hope it
Mm.
is clear to you.
Yes, ma'am.
Okay, good, very good. So this will be your, it will form your carbene. Now you very well know that how carbene will react. For sake of simplicity only I am writing like this, okay. Carbene will be minus positive. This negative charge will go there, will go here, okay. Clear?
Yes, ma'am.
Now what will happen? This bond will go here and this bond will break and it will
Mm.
combine with this positive charge. Understood? What
Mm.
this step is very crucial. Let me explain you again. Oxygen lone pair will come back. If you break this bond, this will be positive, this will be negative. This
Mm.
positive negative will combine and will form your carbonyl. Okay. This double bond is still there. Actually, ketene you have to write in linear form. That's why I am writing like this. Let me explain you again. Oxygen. This is this C double bond C. Now this positive has combined with this negative. Correct?
Mm.
And you will get this. I hope now it is crystal clear to you.
Mm.
Yeah. Now, the solvent that is methanol, it will attack onto this. Obviously, this bond is more electron deficient, C double bond O. So, methanolic oxygen will attack onto this bond and you will get this enol. It will
Mm.
tautomerize and it will give you ester.
Mm.
So, now you have understood Wolf rearrangement?
Yes, ma'am.
Okay. Okay. So you solve these two questions also. This will be your homework. We will discuss in summary session. I think that is on 17th March. Okay, you please attend that. In that session, I am going to cover from your electrocyclic reaction. I will cover all the electrocyclic reaction plus organic photochemistry. Short notes. In that class, we will revise everything so that you can attend that class and directly appear for exam for NPTA. Okay.
Mm.
So you solve first question and first question is a mixed problem. Tell me which name reaction is involved in this.
Mm.
Can you identify?
Ma'am, dipymethane.
But where is skip dying?
Mm. Yeah, okay. Means benzene rings olefin can't be considered.
Very good, Pinky. Here it is. You can write in this resonating form also, right?
Mm.
Now forget about everything and now it is question for your dipymethane. Okay. At which side you will form radical?
Right side, ma'am.
Good. because here that radical will be in conjugation with this whole pH ring, and here
Mm-hmm.
with these two double bonds, and on account, and it is losing aromaticity also. So as you have told me, actually we will see both the possibility and then we can decide. Are you with me?
Yes, ma'am.
Okay.
Listen.
So this is the final answer. Yes or no?
Yes, ma'am. Mm,
And obviously, if you make radical onto this side, then you can't get aromaticity back. है ना?
mm, mm,
So
mm,
this is the only possible answer.
mm,
Not possible, major.
mm.
Okay. So this is your homework, I think. Okay, this is also your homework. Again, example of dipymethane
Right.
rearrangement.
Mm,
Okay. You will get some complex system. All these remaining questions I will take in summary session. Before you leave, let us revise all thing and that one question here. Here
mhm,
I have also made. Basically, if I, for simplicity, let me erase all these numbers. And if I match, yeah, DE, and here 1, 2, 3, 4, 5, 6, 7 membered, 5 membered, 4 membered. Everything is correct. We just have to match our answer.
mm,
If we look at the common carbon between 5 member and 4 membered ring, it is this. Let me number it A and B.
mm.
Okay. And you can write here 5 and 4 membered ring, common carbons are A and B. Okay.
Mm, mm,
Your 5 member and 7 member, B and C, right?
mm, mm,
Your 4 member and 7 member, B and D.
mm.
Till this point, everything is clear, right? Now
Yes.
see, this backside one is your 7 membered ring. Okay.
Mm, mm,
And your 4 membered ring and 7 membered ring have which carbon common? D and B.
mm,
So
mm.
these are your D and B. Now
Yeah.
your 5 membered ring and 7 membered ring have which common? B and C. So B and C. So what C will you take? This one. Okay.
Mm.
This is in your 5 membered ring also and 7 membered ring. I hope you are not getting confused here. Let me
Yes, ma'am.
remove earlier numbers. Then you will be more clear. I said that 4 membered and 7 membered ring have common B and D. B and D. Your 7 membered and 5 membered ring have B and C common. Okay, B and C common. And what is remaining? 5 and 4 is having, this is your 4, 1, 2, 3, 4, and this is your 5. Which are common here is A and B. So where you will put A now?
Mm,
Here. But A and B are connected. Actually, here that four
That's it.
membered ring is
Mm.
not four membered ring, right?
That is wrong, ma'am.
Something is wrong in this product
In
also.
this, one extra carbon have been
One
given.
extra carbon is there. Okay. So this is problem in product only. So our
Mm.
correct product is this. Okay.
Yes, ma'am.
Understood now? No confusion, I think. I
No.
will check this product again.
Mm.
So
Ma'am, I have two doubts from this assignment 7. Uh,
assignment 7. Okay, but I don't have that PDF.
okay. There is, ma'am, one
You can ask me orally if I can help you.
the structure is 5-member ring dienone system.
Wait. You are saying five membered ring dienone like
Mm.
this.
Uh,
Huh.
and all the carbons is having the tertiary carbon. All
Tertiary carbon like this.
one second. I will check.
Correct?
Yes, ma'am.
Now
Tertiary. One second. All the carbon tertiary have tertiary carbons are there. Not this one means that is also substituted by 3 methyl groups. All. Uh,
you are saying like this.
uh,
Huh.
then in that H nu means light in low temperature matrix it has been given.
Low temperature.
Matrix.
I couldn't listen to you that what you have spoke after low temperature. At low temperature, what you are getting?
Matrix. Low temperature matrix it
Okay,
has
okay.
been given.
Matrix. Okay, okay. Hmm.
So here, which product I'm not understanding. Means I have got one, but I'm not
Okay.
sure whether it will be forming or not.
Okay, you just tell me the problems, assignment 7, which problems. I will get back to you in next class. Okay, I will bring those question here and with their answers, right?
Okay, this one, but my submission date I think on this month, this Wednesday is the submission date.
So what you can do is I can share with you my contact number and you send me on WhatsApp
Okay, ma'am.
and I will solve and send you there. Okay.
Ma'am, one more is there in
Hmm.
that problem only. Anthracene 9 carboxyldehyde.
Okay.
And same means under photochemical condition there are two blank position have been given.
I
uh,
somewhat understand your question, but it will be more better if I saw the correct structure there. है ना? So
yes,
you can write my contact number and send me message on WhatsApp with
yes,
both
ma'am.
the question till in 1 to 2 hour I will send you after the
Okay,
class. Okay.
okay,
You
ma'am,
can
please.
write 90
90
79
79
16
16
30
30
43.
4. Okay, ma'am. I'll send you, ma'am, the
Yeah.
PDF only. I'll send you.
Whatever doubts you are having in that PDF, send me that question number.
Okay.
I will solve that and send you the picture.
Mm-hmm.
Okay.
My problem is when I'm collectively trying to solving, I'm completely confused. Means which one is electrocyclic, which one is this organic photochemistry. Everything is confusing.
I know, I understood that. But what I suggest you is that in pericyclic reactions, I have told you, you can bifurcate in two parts. One is single component, one is your two component reaction. In one component reaction, there are two possibilities. Either it is electrocyclic reaction or it is your sigma-tropic reaction. है ना? But in
Mhm.
your electrocyclic reaction, those double bonds are in conjugation. But
Duration.
in sigma-tropic, they are not in conjugation. So
Mm.
there you can differentiate. 4
Mm.
plus 2 is clearly visible. If it is thermal condition given, then only de-Salter reaction will take place. And how to
Okay.
solve all those questions, you know very well. In organic photochemistry, let me show you one slide where we will revise all the reactions which we have discussed today. It is very You are saying, ma'am, whenever I saw the collective problems, I got confused
Mm.
what to apply, right?
Mm.
So in photochemistry, what is funda is, it depends on product given to you.
Mm.
Okay. Mainly, examiner will give you product also, and they will ask for mechanism. And if not, they will give you questions which are clearly telling you that this is the Paterno-Bucchi reaction. So let's start from one. So first reaction which we have today discussed is Norris type 1. So you what you can do is you make one A4, you take one A4 sheet, two
So
A4 sheet,
mother
one
clearly.
for your pericyclic reactions, one for your organic photochemical reactions. Okay.
Okay.
You write reaction name,
Mm.
its what is its main, what we will say, function, any key points to remember.
Mm.
If I talk about Norris type 1, function is alpha cleavage. You very
Mm.
well know that what is alpha cleavage. Alpha cleavage, only two possibilities there. Radical will form, CO will liberate, and those two radical will combine. Okay.
Mm.
So nothing key in that. After that we have covered Norris type 2.
Mm.
It takes gamma cleavage. Gamma cleavage means it take gamma hydrogen actually.
Mm.
It can form two bonds. It can form two products. One is that fragmentation one, and one is your cyclobutanol type products. Yes or no?
Mm.
After that, what reaction we have covered today? I think dipymethane, right?
Mm.
In dipymethane rearrangement, you should know what is your starting material. In these reactions, you will get carbonyl compounds. So, in key points, you can write starting material is your carbonyl compounds. In dipymethane rearrangement, your starting material is skip whenever you just try to find out if you get this type of system,
Mm.
this will clearly indicate that this is question of your dipymethane rearrangement.
Mm.
Then we have come across D-Mayo's reaction. How
Mm.
you will identify whether it is D-Mayo reaction? By seeing change in, if any of your 1,3 diketone is changing to 1,5 diketone, and how they are separating just by that olefin, external olefin you are giving it, right?
Mm.
And key thing is, write one of the ketone in enol form, write one of the ketone in enol form. 2 plus 2 cycloaddition between olefin and that enol double bond, followed by retroaldol. You can write this in your A4 size paper, so that
Mm.
before going for any exam, you just revise those points and do that problem. Or if you are doing practice at your home, just go through these two A4 size paper and you will be able to solve, because every time you can't refer your notebook.
Yes.
Clear?
Yes. Mm.
And after that, what name reaction we covered here? Paterno-Bucchi reaction. It is the reaction between 2 plus 2 reaction between your carbonyl and olefin that occurs in photochemical condition. Regioisomers, I have told you already, combine less to less stable and more to more stable. Okay. And you can write in that A4 size any conclusion if you have made from solving various problems of that reaction, right? Let's say if you are solving 5 problems of Paterno-Bucchi reaction from your Google, and you will
Mm.
see a trend there. You can
Mm.
write that trend in your A4 size paper. That
mm,
whenever for example, I have made here conclusion that we have to combine less stable radical to less and more stable radical to more. You can directly write the product after studying this line.
mm,
After that we have at sixth number, let me erase that part. At sixth number I have Hoffman, Loeffler, Freytag. Sometime name also comes, so you should remember name also. In this delta hydrogen abstraction, at final product you will n hello amines change to your cyclic amines. How cyclic? Delta hydrogen abstraction and amine formation. So this is all the summary of today's class. Yes or no? So from
yes.
every class you can make some short notes and you can revise that. My I'm just solving here two to four
Mm,
problems of particular reaction, but at
mm,
home you should do at least 10 to 20 problems of one particular reaction, so
mm,
that anytime if some question come from that problem you should not leave that.
mm.
And
Okay, ma'am.
always write conclusions from reaction.
Mm,
That how can you directly write the product? Always you should not draw the mechanism. You should
mm.
see the question and directly write the product, right?
Mm,
It will
mm.
save your time also. This
Yes, ma'am.
suggestion is for your competitive exams.
Mm.
Any doubt
Okay.
other than this? Those two
No, ma'am.
problems from assignment I will solve today and send to you.
Okay. Thank
In problems which I have solved today, in that if you have any problem you can ask.
ma'am. I have means I don't know what I'm sure I'm not that much wrong. That assignment one assignment I think 4 or 5. I have got 65 out of 100. I don't know where I'm wrong because I'm
Assignment
not
4 and 5.
4 or 5 something I don't
So
remember.
they don't provide you correct solution after the exam.
No, no, no. They don't provide, ma'am. I check my number. First one is 85, then 75, then 65. Like that, it is reducing. But I'm not. I'm 100% sure that that much wrong. I was not that to get 65 marks.
Okay, for that I will see the assignment you are telling, assignment 4 and 5, na?
4 or 5. I have to check. I'll
Okay,
check
I
and
will
I'll
try
send
to
you.
discuss those problems in summary session
Okay, ma'am.
if time permits. Okay.
Okay, ma'am. Okay, ma'am.
When is your exam?
Exam is 27th.
Oh, still time is there. We will revise on 17, and still
Hmm.
if you face any problem you can
Hmm.
message me anytime.
Okay, okay, ma'am. Thank
Okay.
you, ma'am.
Okay. Thank you for joining the class.
I'm enjoying, ma'am, actually.
Good.
Thank
Th-
you, ma'am. Bye,
Thank
ma'am.
you. Bye.
I'll see you, ma'am.
Yeah.
Okay.